implementing RIP protocol in Cisco Packet Tracer। तो इस मॉड्यूल में हम सबसे पहले जो करेंगे विल ट्राई टू नोट इट डाउन। तो हमारा पहला स्टेप होगा सबसे पहले कि हम एक टोपोलॉजी सेटअप करें। तो सिंपल कनेक्शंस लेंगे, हम 3 राउटर्स लेंगे, ठीक है, और उनके साथ कनेक्टेड 3 PCs होंगे। तो लेट्स सेट दिस अप। राउटर हम यूज़ करेंगे 1941 राउटर आईडी, एंड PC तो आप एंड डिवाइस में ले लीजिए। एंड स्विच का मॉडल लेट मी चेक। स्विच का मॉडल इज 2960। ओके, तो बेसिक टोपोलॉजी बनाते हैं। तीन राउटर्स, ओके, एंड 3 PCs कनेक्टेड टू इट। तो PC कनेक्ट करने के लिए वी नीड स्विचेस 2960। पहला स्विच यहाँ, दूसरा स्विच यहाँ, एंड तीसरा स्विच यहाँ, एंड देन कम द PCs। पहला PC यहाँ, दूसरा PC यहाँ, एंड थर्ड PC यहाँ। यू नो व्हाट, लेट मी थोड़ी जगह बना लेते हैं वरना दिक्कत आएगी। तो दिस इज आवर सेटअप, या कूल। ओके, अब सिंस राउटर में अगर आप ऑब्जर्व करेंगे तो हमारे पास केवल 2 ही पोर्ट्स हैं, लेकिन अगर हम यहाँ देखेंगे तो एक राउटर एक से इस राउटर से, एक इस राउटर से और एक स्विच से भी कनेक्ट होगा। तो वी डोंट हैव इनफ पोर्ट्स, सो व्हाट वील डू इज वील एनेबल द सीरियल पोर्ट्स। तो सीरियल पोर्ट कैसे एनेबल करते हैं, नेक्स्ट स्टेप हमारा होगा enable the serial ports and the serial, okay, and the serial port which we'll be using here is the HWIC2T. Okay, it's a Cisco 2-port serial high-speed WAN interface card providing 2 serial ports, so we'll have 2 extra ports. So what we'll do is first we'll turn off this, and then we'll take it and we'll place it here, and then we'll turn it on. Okay, so this is done for router 1. We need to follow the steps for all routers. Okay, so router 0 is done. We'll do the same with router 0, router 1. Okay, we'll turn it off, then we'll apply it here, and then we'll turn it back on. Turn it off, apply, turn it back on. Okay, so now since both our routers have serial ports enabled, so we can check in the configs that you can see here serial ports are now available. So by default, the connection cable which we'll be using, it will automatically connect it to the serial port. See, you can see here SE0/0/0, which means the 000 port of serial has been established from router 1. See from here, router 0. Okay, now it's visible. Yeah. Here also it has connected to the serial port. So in this manner, we'll connect all these with themselves, this and this. Okay, so they're connected. We do need to remember which serial ports they are connected because for future perspective. So we'll roam it around and see that the SE001 port is connected with the router 0, and 000 port is connected with the router 1. So this can be, if you want, you can note it down, or we can just manually check. So this has been connected. If the serial port is connected, a red like wire should be there like this. And since you can see that the red marker is down, that means the current state is not up. So we'll figure out for that as well. Rest we'll connect all the switches, so it will automatically get connected to the gigabit port. the routers to the switch will be connected via gigabit. But what do we need to keep in mind that the router to router connection should be established via serial port only. Router to router connection to be established via serial port only. uh, and this router to this switch, then switch to PC, and then switch to PC. So this is now our basic topology. uh, okay, so 000 is connected to left side and 001 is connected to right side. Let me check if my mic is working. Yeah, it's working. Okay, so now since our topology is ready, so our next step would be to decide which all IP pools we have to create. So if I want to mention, so this would be one IP pool, okay, because the switch and the PC, this would be another, okay, and this would be another. Then the routers themselves would have connections established within each. So these two routers will have an IP pool, these two routers will have an IP pool, and these two routers will have an IP pool. Now in this method, we are using class C IP addresses. So class C IP addresses will denote in the format of uh, the first three 192 dot uh, wait 255 up to the range of 255. So basically the first three will be mandatory for the class C IP addresses, like 192.168.1.0 will be the class C IP address that we'll be using. The bit that will change will be this bit. So the first IP pool will contain 1.0, the second will 2.0, 3.0, and so on. So here I'll mention it. Now, for easier, noting down facility, we'll write it down that what IP pool we shall decide. It is up to solely your choice what IP pool you should decide. It's just that you need to keep it distinct. So let's start. I'm assigning the switch and this IP pool as my LAN 1. LAN 1 is the terminology that I'm using to differentiate. What matters is that this IP address. Okay, so this will be 192.168.1.0. This will be the one. Okay, and then come to this the between the two routers 192.168.2.0. Okay, now these three these switches, this would be LAN 3 192.168.3.0. Okay, now the router 1 and router 2, which will be LAN 4 192.168.4.0. Okay, this is the LAN 4. Now this one will be the LAN 5 192.168.5.0, and this one is the last LAN 6 with 192.168.6.0. So here you can see, since these are all class 6 IP addresses, so the 192.168 bit will remain same. It's a normal, it's my choice to take it 192.168. You just have to keep the range below 255. So you can choose, 172.155.1.0, 132.1, dot 78. Just the first two bits should be mandatory and first two bits will remain common. The what will change is the this third bit, which will denote the several IP pools that we'll be creating, and the last bit will be obviously the different devices within that IP pool that will be assigned to them. So since we have decided our IPs, let's get them set up. I'm just putting these labels in a clear format so that we can see. Okay, so to assign the IP addresses, we'll use we need to see that which cable is this port connected to. Okay, so starting with the router 0. Okay, we can see that SE000 is connected towards router 1, which has the IP pool as 192.168.1.6.0. So we need to note down that 000 will be connected with the I 192.168.6.0 IP pool. So if we go it here, and this window will open the config file and check serial port 000. Here the IP address, since the router address, it would always be assigned in this form 192.6.1. 6 we have already decided. If you can see it here, we have decided that this will be the 6. So the 000 port, since it's the router one, it will be considered as 192.168.6.1 because it's the first. Okay, and we'll turn this port on. Okay, and by default, since there are only two serial ports, if 0001 is connected with router 1, we can observe that the 000 is connected with router 1, 001 will be connected with router 2, for which we have decided the IP to be 192.168.2.0. So since this is the router being configured, so here we'll 192.168.2.1. Okay, and we'll turn this port on as well, and then since a gigabit device is also being connected, so you can see the gigabit port is also connected, for which we have decided the IP 192.168.1.0. So here we'll write the address 192.168.1.1, 1.1 being we are specifying the router, and we'll turn this port on as well. Okay, so our router 1 is now configured. Now we need to come to, let's say we come to router 1. Okay, so we'll click this, where's the window? Yeah. So we'll come into the same. Now we need to observe this as well, which is being connected with which. So if we take it a bit far, we can observe that 000 is connected with router 0 and 001 is connected with router 2. So since 000 is connected with router 1, router 0, yeah, 000 is connected with router 0 and 001 is connected with router 2. So 000 already has an IP pool of 192.168.6.0. So what we'll do is we'll take this, and since 000 is connected with IP pool of 192.168.6.0, so 6.1 has already been assigned to this router, so the next router will automatically get the address 192.168.6.2. Okay, so since 000, the serial port 000 is connected with this router, and this router already has an established IP pool of 192.168.6.0, wherein 6.1 has been assigned to this router. So since IP addresses are unique, 6.2 will be assigned to this router, and we'll turn it on. So if you can see, as soon as I turned it on, the interface serial changed to up. So since both the IP pools matched, this arrow is now green. Okay, so this is a very nice, this is establishing connection. And since automatically if 000 was connected with the 192.168.6 dot pool, then 001 is connected with the 4 dot pool. So I'll assign this IP address as well, 192.168.4.1. And since now this is the first device in the fourth router, in the fourth IP pool, so this will simply remain as 4.1, and this is fine. Now for the gigabit part, we can see that gigabit 00000 is connected with the IP pool which we have decided 192.168.5.0. So here I'll write 192.168.5.1. Okay, and we'll turn it on, and you can see this has also changed the state to up, which means the connection is now up. Okay, so this is done for router 1, and we'll close this. The same step needs to be applied for router 3 here as well. So now we can see, before that we need to see that which is connected with which. So we can see that 000 is now connected with router 1 and 001 is now connected with router 0. So for first we'll configure 000. So we can see that 000 is connected with router 1 and 000 already has an IP pool established of 192.168.4.0. So we'll come to our config panel of router, and we can see here, okay, that 000 was connected with this router, and this router has an IP of 192.168.4.0. Now herein we assign the 4.1 to this router, so automatically here we'll assign 192.168.4.2 to this router, and as soon as I click it on, its interface should be changed to up. So the connection has been done and the interface is up, and you can see a green arrow has appeared. And since automatically the 001 port is remaining and it is connected to the 192.168.2.0. Now since we decided here that 2.1 was assigned to this router, so automatically 2.2 will be assigned to here. So if we check 192.168.2.2, because this is the second router in the IP pool, and we turn it on, its state has also changed to up. Okay, and now this router also has a gigabit part, so we'll go to the gig 00, and this has the IP pool decided of 192.168.3.0. So here it is, 192.168.3.1, since because this is the router. Okay, and we click it, and it has a rest message, and we close. I think wait, I opened the switch. Why have I opened the switch? This router, did I mention the router address as 1? Yes, I have mentioned it 1. So since it's the first device in the network, it will be 1. And these IP pools have two routers. That's why 1.1 was assigned here and dot 2 was assigned here. So we have configured the router address, and now we have also configured the PC addresses. So now what we need to do is we need to go to each PC. Okay, so we'll start with this, and we know that 192.168.1.0 is the IP pool. So we'll go to desktop, and we'll go to IP configuration, and for the IPv4 address 192.168.1.1 was assigned to this gigabit port. Okay, so since 192.168.1 is already preoccupied, so this PC will get the IP address 192.168.1.2. Okay, and the subnet mask comes by default. Now here comes the tricky part. For each PC's default gateway, you need to enter the router address that you assigned it to here. So here the IP address was 192.168.1.1. So in the default gateway panel, you write 192.168.1.1. So in the gateway default gateway panel, you'll your default gateway input, you'll give the address that you assigned it to the router's gigabit port. Okay, and now this is done, so we'll close it. We'll follow the same procedure on all the remaining PCs. So here we can see that we decided the pool of 5.0, so we'll go to the IP configuration, and since 5.1 is already been assigned to get this gigabit port, so here we'll do 192.168.5.2. Okay, so since 5.1 was already assigned, and for the default gateway part, we'll mention the router address 5.1, which was assigned to the gigabit port. So this step is clear now, and same we'll follow this for the last router. Uh, okay, last PC, sorry. And we'll go to desktop, we'll go to IP configuration, and since this is IP pool 192.168.3.0, and since 3.1 was already assigned to this gigabit port, so 3.2 will be assigned to the PC, and the default gateway is the router address, the default 192.168.3.1. Okay, so now we have configured all our IP addresses and all our devices are connected, and we can see all green, all switches are green, and up. So just there is one part remaining, that each router you need to, now we have a list. Okay, how many list of you know list of IP groups. So the first one is 192.168.1.0, then 192.168.2.0, then 192.168.3.0, then 192.168.4.0, then 192.168.5.0, and we have 6 as well. So 192.168.6.0. So these are the IP pools that we have, and so what we need to do, we need to go to each router and click on this router, and here in the config panel you will see in the routing stating RIP. So what we need to do is we need to add all these IP groups that we have decided into the network RIP table. So the method for this is, in the network, go just 192.168.1.0 and click on add. Okay, and 192.168.2.0 and click on add, 192.168.3.0 and click on add, and 192.168.4.0 and click on add, 192.168.5.0 and click on add, and 192.168.6.0 and click on add. So this has been done for the router. You can prefer the GUI panel as well, or equivalent Cisco packet tracer has already provided equivalent coding commands. So if you can the CLI panel, you can do this as well. I would prefer the GUI part, because it is much more easier. So all the IP address you can check once again is .1.0, 2.0, 3.0, 4.0, 5.0, 6.0. All of this has been added, so you can now close this router. Same steps should be followed in the remaining routers as well. So you can go to this in this config panel in the rib, and you need to add the all the pools that you have created in your RIP table. Okay, so 192.168.1.2.3.4.5.6. Okay, so all these pools have been added in this address as well, and just we'll do this for the last last router as well. Okay, so 192.168.1.2.3 all the so now all our steps have been completed. I did not note it down in this text file, but when I'll upload the video, I'll update this document step by the step by step procedure. So I'll close this right now, and this is the final working of all the ports and implementation of the RIP protocol. I'll add a note here as well. Implementation of RIP in CPT. Okay, so what we'll do is we'll try to send a PDU. So because of the address resolution protocol, the first PDU will fail. Okay, and see, the first PDU has failed because it takes time to update the addresses of all the memory. But if I send a second PDU, it should be successful, and it is success. It has been successful. So this is because of the address resolution protocol, which we'll study in the theory part, or you can read up on it. This basically have what basically happens is the routing table is not updated of the respective IP addresses where we're trying to send. It has the IP groups, but it needs the respective IP addresses as well. So the first time it collects all the IP addresses, and because of that, the first PDU fails, but subsequent PDUs get passed. So this was the CPT implementation of the routing information protocol, also known as RIP. And thank you for watching. Hope you learned.